Hello, welcome back to the Cosmic Classroom. Now, I have a question. Why is it that Newton had that weird insight that the same reason that an apple is falling on the ground is the reason why the moon is going around the earth? What was he thinking? What sense does it make? So, I've come to expect that students will always tell me that yes, it's the same force that causes the moon to fall on the ground. It's the force that causes causes the apple to fall on the ground. It's the same that causes the moon to go around the earth. But why? They seem very different, right? What's going on? So the apple is attracted gravitationally to the earth, and therefore it falls, and the moon is attracted gravitationally to the earth, and therefore it orbits. That doesn't make sense, right? One is falling, the other is orbiting, but it is the same force. What's the secret here? So the secret doesn't have anything to do with the masses of the moon, the masses of the apple. It has to do with the fact that the moon has a horizontal velocity also. The moon is not just starting from rest and falling down. The moon has a velocity, and the moon is moving to the side at the same time that's being attracted to the earth. And it keeps missing the earth and keeps falling and falling. If there was any way that we could stop the moon in its track, it would fall right down the earth. It's the fact that there is that velocity, that horizontal velocity, that makes it keep orbiting and missing the Earth all the time, right? So there are a few different ways of understanding that, and it's really the same physics stated in a different way. So one is to think about, for example, in this figure we have the Earth going around the Sun, which is a similar idea. This is not to scale, and this image is much more elliptical than the orbit really is. But just to give you an idea of what's going on, there is a horizontal velocity here, which causes that the Earth to not fall directly into the Sun, but fall and continue moving. And that's what puts it in orbit. It's this velocity here, this initial horizontal velocity, that's the difference between the moon falling, the apple falling, and the moon orbiting. And it can be thought of in two different ways. You can think about this problem as conservation of angular momentum. The angular momentum, if you recall, is the product of the mass, the velocity, and the radius. So, the Earth has always the same angular momentum. When it's close to the Sun, the radius is small, the velocity is large. When it's far from the Sun, the radius is big, the distance is big, therefore the velocity is small. So what keeps the Earth in orbit around the Sun, and what keeps the Moon in orbit around the Sun, around the Earth, is the conservation of angular momentum, or centripetal force, the fact that there is a perpendicular velocity, okay? That's what keeps the Earth from falling into the Sun and the Moon from falling into the Earth, unlike an apple. If you did give the apple a good push to the left, high enough, it would keep falling and never reach the ground. That's why if you fire a bullet with a certain horizontal velocity, it's going to take a while to fall. It won't directly fall because it has a horizontal velocity, right? Now imagine firing that bullet with a velocity that's high enough. It would go around and hit you in the back. That's orbiting. I hope you're now convinced that yes, indeed, it's the moon. It's the same force of gravity that attracts the apple to the Earth and attracts the moon to the Earth. The effects are different because of that horizontal velocity, initial horizontal velocity. I hope that helped. I'll see you next time.